Hi guys, welcome back to my channel. Today, we're going to explore another fascinating mega machines topic. Have you ever wondered how concrete gets to the very top of a 50-story skyscraper? No cranes, no buckets, just raw power. Meet the mechanical beasts that can shoot concrete 600 feet into the sky like it's nothing. These are the most powerful concrete pumps in the world, machines so strong, they helped build the tallest structures on Earth and even aided during nuclear disasters. In today's video, we're diving deep into the extreme pressure, cutting-edge technology, and jaw-dropping power of concrete pumps that are redefining modern construction. Get ready, because this is going to blow your mind. When we look at a stunning skyscraper piercing the clouds, a massive dam holding back millions of gallons of water, or a stadium filled with thousands of cheering fans, we often marvel at the architectural design and scale. But rarely do we think about the invisible lifeblood that forms the very core of these structures, concrete. And while concrete might sound mundane, the machines that move it into place are anything but. Welcome to the world of the most powerful concrete pumps on Earth, where technology, pressure, and engineering brilliance come together to push wet concrete up to 600 feet high, and sometimes even beyond. Let's begin by understanding what a concrete pump actually is. In its simplest form, a concrete pump is a machine that transfers liquid concrete through a pipeline using powerful hydraulic pressure. But when it comes to today's mega construction projects, these machines aren't simple at all. The pumps used to deliver concrete to extreme heights are high-performance marvels designed to deal with one of the most challenging materials in construction. Concrete is incredibly heavy, thick, and time-sensitive. Getting it to the right place before it sets, especially 40 or 50 stories above ground, is no easy task. That's where these engineering monsters shine. The most iconic and powerful pump truck in the world is the Putzmeister M70-5, built by the German manufacturer Putzmeister. It's the largest truck-mounted boom pump currently available, with a 5-section, 70-meter-long boom arm that's over 230 feet. This machine can unfold, extend, and maneuver through dense construction zones to deliver concrete exactly where it's needed. But when you combine this pump truck with stationary high-pressure pumps and vertical pipeline systems, it can help pour concrete at mind-blowing heights of 600 feet or more. One of the most astonishing applications of powerful concrete pumping happened during the construction of the Burj Khalifa in Dubai, currently the world's tallest building. In this megaproject, concrete had to be pumped to a record-breaking height of over 2,000 feet, 630 meters. Standard equipment simply couldn't handle this. To achieve this, a custom-made Putzmeister BSA 14,000 SHPD pump was used. It was capable of generating pressure of over 600 bar, 8,700 psi, enough to shoot concrete higher than ever before. The operation had to be so precise that engineers poured only at night, when temperatures were lower, to prevent the concrete from setting inside the pipes. Even the smallest mistake or delay could result in the entire pipeline being blocked, which would be a disaster at that height. But why go to such lengths? The reason is efficiency, safety, and structural integrity. Using a crane to deliver concrete in buckets is time-consuming and risky at extreme heights. A pump, on the other hand, delivers a continuous flow of concrete exactly where it's needed, whether that's on the top floor of a high-rise, the inside of a bridge pillar, or the core of a wind turbine. This constant flow also ensures there are no cold joints, which are weak points formed when concrete is poured in batches instead of a single continuous stream. Another industry leader pushing boundaries is Liebherr, with their versatile 50 M5 XXT concrete pump truck. Though it doesn't match the M70 in boom length, the Liebherr 50 M5 offers something equally valuable: flexibility and control. It has a 5-section boom that can reach deep into narrow city spaces or weave around steel reinforcement. With smart hydraulic systems and advanced software, this pump allows for smoother operations on complex sites like underground tunnels, overpasses, or multi-level parking decks. These pumps aren't just built for height, they're built for volume. At full capacity, a single high-performance concrete pump can move more than 200 cubic meters of concrete per hour. That's roughly 525 tons of material in 60 minutes. Imagine a small swimming pool, now imagine that being filled with wet concrete in just minutes. These machines operate with incredible power and precision, saving time and money on massive construction projects across the globe. However, concrete pumping at high altitudes brings with it numerous challenges. One major factor is gravity. As the height increases, so does the back pressure in the pipeline. This means the pump has to work harder and generate higher pressure to keep the flow moving. And concrete is not water, it's a viscous, abrasive mix of cement, water, sand, and aggregate. The friction inside the pipeline can be enormous. To combat this, engineers use specially designed pipe materials, apply lubricating slurries, and closely monitor the temperature and viscosity of the concrete. But pressure and pump strength aren't the only concerns. Safety is also paramount. A rupture or blowout in a high-pressure pipeline can be catastrophic. That's why modern concrete pumps are equipped with dozens of real-time monitoring sensors. These sensors detect pressure changes, blockages, vibrations, and even chemical separation in the mix. Operators in a control cabin or even remotely from a tablet or laptop can adjust settings and shut down operations immediately if something goes wrong. For skyscrapers or tall structures that exceed the reach of any boom, construction crews rely on stationary concrete pumps, which are mounted at the ground level and connected to a vertical line system. These pipes are anchored to the sides of the structure and extend upward as the building rises. During the construction of Taipei 101, engineers used multi-stage pumping where concrete was pumped from the ground up to a mid-level staging area and then boosted again to the upper levels. It was like a baton race, but with tons of liquid rock. One of the most fascinating roles of powerful concrete pumps isn't even in construction, it's in emergency response. After the Fukushima nuclear disaster in 2011, several massive concrete pump trucks were flown from Germany to Japan on the world's largest cargo aircraft. Their mission? Use the long booms to pour cooling water and eventually cap the damaged reactors, all from a safe distance. These concrete pumps helped prevent further catastrophe and became part of disaster response history. Let's take a moment to appreciate the people behind these machines. Operating a massive concrete pump is no small feat. These machines can cost over $1 million and require highly trained professionals to operate. Boom operators use remote control systems that allow them to adjust the boom's position with surgical precision even from hundreds of feet away. Coordination with the team on the ground is essential. A single wrong move could knock over formwork, damage rebar, or even injure workers. And technology continues to evolve. Manufacturers like Schwing, Sifa, and Zoomlion are now integrating AI-based systems into their pumps. These AI tools can automatically adjust pressure based on pipe resistance, detect anomalies before failure, and even recommend maintenance schedules. We're entering an age where smart concrete pumps will make real-time decisions on the job site, reducing human error, boosting safety, and increasing efficiency. Concrete pumps are also becoming more environmentally conscious. Newer models include hybrid diesel-electric engines that reduce carbon emissions on urban sites. There's growing research into carbon-neutral concrete mixtures, and the pumps of the future will play a role in ensuring sustainable building practices. Another exciting innovation is robotic concrete printing, where powerful pumps are used with 3D printing nozzles to create pre-designed structures layer by layer. Some companies are already using this technique to build homes in under 48 hours, with smart pumps controlling the flow of high-performance concrete. 3D printing of large-scale structures could soon become mainstream. In conclusion, concrete pumps might not be as flashy as tower cranes or as massive as tunnel boring machines, but their importance in modern construction cannot be overstated. The ability to pump concrete 600 feet into the air with precision, speed, and safety has changed the way we build our cities, highways, and infrastructure. These powerful machines represent the fusion of mechanical engineering, hydraulic science, and human innovation. Without them, the towering cities we see today simply wouldn't exist. From the towering skyline of Dubai to emergency rescue missions in Japan, concrete pumps have proven they're more than just machines, they're modern engineering legends. As we continue to build taller, stronger, and smarter, these powerful pumps are the silent giants making it all possible. If you enjoyed this look into the incredible world of mega construction tech, don't forget to like, subscribe, and hit the bell icon so you never miss a video. Got a favorite mega machine? Tell us in the comments below. Until next time, keep building, and keep dreaming big.